Hi, I've got an LG 42-inch 42LW5700, which I'm going to have a look at. The symptom was it just switched off, so obviously it's a power supply issue, so let's crack it open and see if we can figure out whether it's something easy fix or not. I've got a new high camera shot, which will probably mean you'll see a lot of the top and the back of my head. Where do you start? There's a bazillion screws in it as far as I can tell. I've downloaded the service manual. In fact, there are many service manuals, one for each region. This one is the TA version, so it's the 42LW5700-TA, along with a dot, 2 A's, U, Y, U, L, N, Y, L, H. Anyway, I've got it sitting on a reasonably thick towel to protect the front, and I've had to clean my desk. Room. The monitor's like 1 metre across in width. Alright. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 screws. 21. At least 21. There's possibly another 3. Oh, that's for the mains cable. The mains cable's unplugged. Let's put that to one side. There was 2 more underneath under the stand. So there's a serial port on PCs. You normally have to take those nuts off, but it looks like you don't need to on this. Yep, fast to come out. It's not a soft tapper, it's a metal thread. So it's 3 different types of screws so far. So yeah, they'll have to come off the rear mounts. Wow, must be up to 30 by now. Gonna need some more tubs. They're going to come off, I think. those. There we go. So it's important to have a quick look around. So that mains cable that went in there. Okay, so before I go much further, I'm going to look up on Earth. I've just got my little filter which I've got plugged in, and just as a final check I just make sure that the earth between the points that I'm going to be using are okay. From PowerPoint, bugger all, and the other PowerPoint, bugger all. Okay, so what do I want to do? What I'm doing is I'm going to earth the chassis. Using this plug so that even when I have this unplugged, it's still going to remain earthed. Just cautionary, it's unnecessary, but use one of these metal threaded ones. Will that fit? Yes, beauty. Make sure there's no AC voltage on it, and then I'll measure the resistance. .6 ohms. Got my ground strapped in for them, but before I start going any further, I'm going to make sure everything's discharged. It's been sitting for over a week, but it's probably a good idea to double check, and it's a good habit to get into, because when I am testing it I will need to be certain. Got the mains connector coming in. Brown is active. This sort of light blue is supposed to be cyan, neutral, and the green and yellow is earth. These will be common mode inductors, chokes. And that's a bridge rectifier. Probably another choke. Common mode choke. Q, D. Alright, so this will Q. Okay. Here's a trick. So you notice there's a black line running down here, goes across. Theoretically, goes across there on a diagonal, joins up with this line, right? And right here it says primary, and here it says secondary. So this is clearly the main side, and this is all of the stuff in here will be like low voltages in quotes. On the Aussie plug, that's the earth, and that'll be active, neutral. Okay. There's continuity on this thing. So that'll be active. Okay, I've got the buzzer off. So it's 0. So I'm getting ahead of myself here. Just a quick check is make sure there's no voltage on here. Okay, so there's no voltage between the active and neutral. The reason why you would do that is just in case, let's say that, I believe that's the rectifier for this. The mains comes in, and obviously going through a choke, through a fuse, and some filtering here, a varistor by the looks of it, a thermistor, small capacitors, and so alright. So see the winding on that. Right, so that will be likely to be active, that will likely to be neutral. And another stage. I obviously want to get rid of anyway, so what I was saying is that the mains is rectified, so it basically uses a bridge rectifier. If the bridge rectifier is buggered, these look like the storage caps. That's only interesting. It's a long way away. That's 100 volts. Yeah, must be these. And there's another set over here. Another set of diodes. Okay, so that there's obviously this is probably standby power, and that will likely be the main power. Oh yeah, and that transformer would be for all the main power. So this would be standby, and this would be your main. Alright, so what happens is it comes in, it gets rectified, and it gets stored on the capacitors. If for some reason, like say these transistors get blown to pieces, it could retain charge. Now, like I said, it's been a week, so it's unlikely to have any charge on it now. And I suspect with all my handling, I know it hasn't got any, because I haven't got that. But let's assume that there was, in this case, probably 340 volts, 339 is the peak of 240 AC. Would be about 340 volts DC on here. If that was blown, if it was short, I should say, if it had gone short, and these switches were open circuit, then it could in theory get zapped back through here. So that's why you check for DC on here to begin with, and then you check for DC on these caps. So 0, and there's obviously another set over here. 0, 0. And this is on the secondary side, 100 volt caps. I don't need to check the secondary. Well, anyway. Alright, so what we can do now is we can check for continuity. So that's a fuse. 0. Let me use my, I don't want to turn the beeper on because it's a pain in the butt, it's really loud. Let me use this one. Can you see what I'm doing? Yes. Not particularly fast. So that fuse is fine. And here's another fuse over here. That's fine. Oh, and another fuse. That's fine. We check for shorts between the active and neutral. No short there. We can check on. Looks like I can do that. So I've confirmed that's the rectifier for the mains on this side. There's a bunch of diodes here as well. Okay, so what we know so far is that there's we've got connections all the way up to the rectifier, and we haven't got any shorts, and so I think at this stage we could be pretty safe in giving it a quick power up test. Now, I downloaded the service manual for this thing, and they don't appear to have anything in any major way talking about this board, this power supply board. So clearly they don't want people touching it. It's possible that the lawyers have gone into contact with them and told them to remove all references to the power supply circuit. But they did talk about a connector. 201. Yeah, I think it was this one. They showed pictures. Yep, 201. So that's 201, and they've reprinted what the voltages should be like on there. So we should go to So we've got a power LED on over here. You can see it. So this power LED is on. It's red. So we've got mains here, so we need to be careful. Okay, so I don't want to be, one thing I don't want to do is lean up against the cable just in case I use high voltages and for some reason I pierce the insulation. Okay, so this is our primary side. This is all the dangerous stuff. You need to be really careful. Really careful. So there's probably, on the right, DC, yeah. Here we go. 308 volts. Do you know what I'm touching there? And even on the negative side, there's like 7 volts there, which no, it's probably floating. These little diodes here are probably the regulators for that. These. There's a chip there. A6059H. SK112. I think it's probably a Senken or something like that. Eight-pin dip with pins missing, is it? Oh yeah. 7-pin dip. You won't be able to see it from that angle, but there's 4 on this side and 3 on this side. This one, the second from the bottom on this side is missing. Which is 605X's operate 67 kilohertz. 605.9 MOSFET on resistance 6 ohms. Power out 17 watts. Adapter open frame. What the hell does that mean? So it's between. Oh, okay. So you've got different voltage ratings as well. So 230 volts AC, you can go up to 17 watts, and on 265 VAC, or between 85 and 265, you can have 11 watts. And open frame, that'd be so. Yeah, so it's definitely the standby power. Power on. 24 volts. Ground. 3.5 volts. 3.5 volts. Ground. 12 volts. 12 volts. 12 volts. And no connection. So 24 and 12 volts missing. Oh, probably not on, right? Standby. So if I switch the power, you hear a click. LED's on. No. The LED's slowly blinking on and off. Right, so first we need to be bloody careful here. We've got bloody mains. Should really make sure this is not conductive. My other meter. Go on 2 gig ohm range. Open circuit. Right, reasonably safe. If you can't measure 2 gig ohms, it's going to be pretty safe. So I'll double that up. Doesn't need to be. How hot's this stuff? Not particularly hot. Click. First pin 3.4, so that was 0 before, so that's power on. 24 volts. No, yeah, it's ground. 3.5 as before. 3.5 as before. Ground. 12 volts. 12 volts, 12 volts, 12 volts again, and no connection. And the other side is pretty much going to be the same, except we've got an error, which is an interesting signal. We all know we'll get. PWM, no connection. Drive on, VSync. DRV on. So there's two windings on the secondary on here. There's only 2 diodes. So I'd say that provides us our 3.5 volts when it's off. Okay. I'm just getting a feel for where bits are. It's off. 24 volts is 0. Ground, 3.5. That 3.5 would be coming from this guy here, so it would be AC of some kind. Shit. Be careful, man. 3.5. 3.5. So yeah, that'd be giving us our 3.5 standby voltage. Just like a center tapped using so a 4-way bridge using a center tap transformer. Operating at, I'll use the AC, because that's got a higher range on this meter. .8 kilohertz, 3 kilohertz. Like 2 volts AC. Should probably do it between. kilohertz. Okay, on AC range, that particular meter is supposed to be able to go to 100 kilohertz, but it's operating at 21.8, 22 kilohertz. Some funny business going on there, but anyway, that's beside the point. Now we need to take a look at this second board. I shall be back after I have a read of the manual.